Yeah, good morning and welcome to OG's Wealth of Math. In this video, we'll be looking at change of subject or formula. We started with algebraic processing. If you look at my previous video, we did algebraic processes 1 and 2, and then we look at all methods of solving quadratic equations. So today we'll be looking at change of subject or formula. Now, what do we mean by change of subject or formula? Now, basically, if you remember that if you have a question like 2x minus 5 equals 11, now if the question says you should find the value of x, it means that the subject of formula for this expression is x, all right? So if we want to do that, we'll just add 5 to both sides, and then we have 2x equal 5 minus 5 is 0, 5 plus 11 plus 5 is 16. If you divide through by 2, x will be 8. So now, let me change the mode of the question. Let's presume we have ax minus c equals d. Now the question says we should make x the subject of the formula. Now it's basically the same thing you do when you solve problem in linear equation. Basically, that's what you do. You just want to express x in terms of other variable. So in this case, because we want to make x the subject of formula, what it means to make x the subject of formula, it means that we want to express x in terms of a, c, and d. Basically, that's what we're doing. So here, we have ax minus c equals d. So I'm going to add c to both sides. And then I have ax equals d plus c. So I want to make x the subject, so I'll divide through by a. So my x will be d plus c, but you can do it in alphabetic order, c plus d all over a. So this becomes our answer. So this can also be said to be a in terms of c, in terms of a, c, and d. All right? So let's take more problems. Now we know that the perimeter of a rectangle is 2 bracket L plus B. Now, if this is the perimeter of a rectangle, and we are asked to express B in terms of P and L, or they ask us to make B the subject of the formula. So there are two ways you can do this, or two or more approach. So the first thing we want to do is either you divide through by 2, 2 will cancel 2, and then you have P half equals L plus B. So you can take this to the other side. So P half minus L equals B. So this is B in terms of P and L. If you don't want to solve it this way, you can open up the bracket where you have P into 2 bracket L plus B. You can open up the bracket by doing 2 times L will be 2L, 2 times B will be plus 2B. So what do? We want to make B the subject. So we're going to subtract 2L from both sides of the equation. If we do that, this is 0, so I'll bring down 2B. So this is P minus 2L. So I'll divide through by 2. So this will cancel this will cancel this. So my B will be P half minus 2. Pretty simple, all right? So let's take more problem. Now, we can have, okay, we know that interest is principal times rate times time over 100. We are all very familiar with this relationship. So if I want to find the rate, I want to make the rate the subject of the formula. So what I need to do here is either we go by either you cross multiply or the LCD is 100, multiply through by the LCD each term, 100 multiplied by I, 100 multiplied by PRT over 100. So 100 will cancel out 100. So you have 100I equals PRT. So I'm using this way because I started with teaching you how to make use of LCD. When you have any expression in fractional form, you look for the lowest common denominator and then you multiply the equation through by the lowest common denominator. So that's what I did here. So we want to make R the subject, so we need to divide through by PT over PT. So PT cancel out PT. So R will be 100I all over PT. Now, this can be said to be that R is expressed in terms of I, P, and T. All right. So sometimes you might be asked to express R in terms of I, P, and T. All right. Expressing R in terms of I, P, and T. All right. So let's proceed. Now let's solve um, problems that has to do with fraction. In fractional form. Let's say we have 1 over F, 1 over U, plus 1 over V. We want to make V the subject of the formula. Now, if we go by what I said, whenever you have an expression, in a fractional form, we make use of LCD. Now, if we want to find the lowest common denominator, if you look at all the denominators are F, U, and V. So our LCD will be F, U, and V. So basically, if you watch my previous video, you multiply through each term in this expression by the LCD. So there are three, we have this term, we have this term, we have this term. So I'm multiplying each term by the LCD. So this will give rise to FUV multiplied by 1 over F equal FUV multiplied by 1 over U plus FUV multiplied by 1 over V. So you multiply each term by your LCD. The reason is because we want to change the orientation of the question. We want to change it from, the fractional form to, a linear form, a straight form where we have the equation in a straight line. So this can cancel out this. So we have UV multiplied by 1. You get UV equal, U will cancel U, so we have FV multiplied by 1, we have FV, plus V will cancel V, so FU multiplied by 1, we get FU. Now, because we want to make V the subject, now you can see that this contains V, and that contains V as well. This contains V, and this contains V. So I need to bring them together. So this is UV. If I subtract, FV to both sides of the equation, if I subtract FV to both sides of the equation, so this will be 0. So I have UV minus FV. So FV minus FV is 0, so I have FU. Another way is I can take this to the other side, if that's what you understand. So you still have UV minus FV, all right? If you're taking this to the other side, if it's a positive, if it crosses the equality sign, it becomes negative and vice versa, all right? So now, this is my new expression. Now, I have V here, and also here. There is V here, there is V here. So I can factor out V, all right? Now, if I factor out V, what I'll have left to be U minus F equals FU. Now, remember that if I multiply through by V, I'm going to get back this expression. So finally, I'm going to divide the equation through by U minus F, U minus F. So this will cancel out this. So my V is FU over u minus f. So this is the expression. All right. So you can copy that very quickly. Let's take more problems. Now, if we have something like x squared equals y over z, and the question says you should make x the subject. Now, there are two approaches you can look at this. Now, if you want to make x the subject, you know the power of x is this. So it's either I find the square root of both sides, or I try to get rid of the power because I want to make x the subject, all right? So please remember that. So it's either I decide to find the square root of both sides, taking the square root of both sides, or alternatively, I can decide I want to get rid of 2. So if I want to make 2 to be 1, sorry, not getting rid of 2. If I have 2, if I want to make it to be 1, I'll multiply it by 1/2, which will be 2/2 over 2/2. 2 over 2, sorry, will give me 1. If I have 3/2, if I want to make it 1, I'll multiply it by the inverse, which is 2 over 3. It will give me 1 over 1, which is 1. All right? So I want the power to be 1. So I'll multiply both power by 1/2. All right? So I'll multiply both power by 1/2. So for this cancel this, x will be the square root of y over z. So if we want to look at this power will cancel this power as well. So x will be y over z raised to the power 1/2. So in this case, my fractional denominator, will becomes the root of the base. So it becomes the second root of y over z. But I don't need to put 2 here because square root is actually the 2 roots, but we can leave our answer as y over z, the square root of y over z. All right? So that's all about that. Now, so I just want to, so if I have, it doesn't necessarily have to be 2 if I have this raised to the power y squared over z. Now, this is 3, so I'll find the third root of both sides. So whichever way you cancel this, x will be the third root of y squared over z. All right? Now, let us see how this is how to convert power to their root form, whether it is the square root or the third root or the fourth root or the fifth root, it doesn't really matter. Now, what about if we have it in their radical form? If I have the square root or the third root of y over x equals z, and the question says I should make x the subject. Now, if you look at this is in the root form or in the radical form, and I want to make x the subject of formula. So what I should be looking at is that I need to get rid of this root. Do you understand that? So if I want to get rid of the root, I'm going to find the cube of both sides. So remember, when we have x cubed, and then we have y squared over, I'm taking you back. When we want to get rid of this, we won't want to find x, we find the third root of both sides. The cube root, or the cube root of both sides. Now, if we want to convert from roots, we want to get rid of this root, we'll find the cube of both sides. All right? The cube of both sides. So we'll find the cube of both sides. The cube of both sides. So this cube will cancel the roots. So I have y over x equals z to the 3. All right? So you can cross multiply, or you divide through by your LCD, but you can cross multiply. Just cross multiply. You have xz cubed equals y. So divide through by z cubed. So my x is equals to y over z cubed. It's pretty simple, all right? Now let's take more problems. Let's take another one. Let's say we have um, I equals e over the root of r squared plus w squared L squared. And we want to make r the subject. Now, if we want to make r the subject, in this case, r is within the root here, so we can cross multiply. If we do that, we're going to get I into bracket root r squared plus w squared L squared equal E. So that's the first thing. Now the second thing we need to do, let's divide the equation through by I. So I will strike out I. So what next? We have the square root of r squared plus w squared L squared equals E over I. All right? Now, the next thing is that we have this in the root form, and we want to get rid of that root. All right? So this means the square root. Square root, like I rightly said, means the two root or the second root. So in order to get rid of the square root, I need to find the square of both sides. All right? So if I find the square of both sides, this will cancel out the roots. So I have r squared plus w squared L squared equal. So this will be E squared over I squared. Now the next thing I want to do is I want to make r the subject. So I need to take this to the other side, or adding this to both sides of the equation. So if I add this to both sides of the equation, if I subtract w squared L squared to both sides of the equation, subtract it to both sides of the equation, this will be 0. So I have r squared. Okay, sorry, let's go here. So I have r squared equal, this minus this is 0, obviously, so I have E squared over I squared minus W squared L squared. So it's either we do that or you take this to the other side, so you still get the same thing. So we are not done yet. So we can decide to put this we want to find a common denominator for this. All right, so we can, our common denominator could be I squared, can be I squared for this and this part of the equation. So I squared in I squared is 1. 1 times this will give me E squared minus, so this is 1. 1 in I squared will give me I squared. I squared multiplied by everything here will give me W squared L squared I squared. All right? So I have r squared equals that. You can see that. All right? So r will become the square root. I want to get rid of the root, so I want to get rid of the square, so I need to find the root of both sides. So this cancels it. So r will be the square root of E squared minus W squared L squared I squared over I squared. All right? So So you can see that. So you can try to find the square. You can find the square of e squared, the square root of e squared, and each of them. So for this, you can have r equals e squared minus w squared l squared I squared over I. The square root of the denominator will just give you I. All right. So let's solve. Let's go ahead and solve more problems. Okay, let's presume we have S equals WD over H into brackets H minus D half. Here, they want us to make H the subject of the formula. All right? Now, if you want to make H the subject of the formula, it's either this side, okay, you want to make H the subject. So what we need to do here is you can decide to open up the bracket. All right, so we have S equals, if you open up the bracket, WD over H, if you multiply it by this, you're going to get WDH over H. If you multiply this by this, you're going to get minus WD squared over 2. So that shows that H here will cancel out. Sorry, let me look at the question again. WD over H minus D half, okay? All right, so if you open up this, you have, okay, sorry. So this is, this would be, this time, this is this, okay, 2H here. So this will cancel out this, all right, so that's correct. So we have S equals WD minus WD squared over 2H. Now we want to make H the subject. Remember, I want to make H the subject of the formula. So what we need to do here, you can decide to divide through because you want to get rid of the denominator. So we can decide that our LCD is 2H. So multiply the equation through by the LCD. All right. So that's another way to look at it. So if I multiply the equation through by the LCD, our LCD is 2H. So if I do that, I have 2H bracket S equals 2H bracket WD minus 2H bracket WD squared over 2H. Now, I hope you understand what I'm doing. Now, from this expression here, we want to make H the subject of formula, and you already understand the concept of lowest common denominator. So we need to multiply each term in the expression by the lowest common denominator. The lowest common denominator is actually 2H. So I'm multiplying this, and this by the LCD. So here, this will cancel out this. So I have 2HS equals 2HWD minus 2. So 2 cancel 2 as well. So I have minus WD squared. All right? So because we want to make H the subject, I have H here and I have H here. So what am I going to do? So what am I going to do? Since I have H here and I have H here, what am I going to do? So I want to take two of them together. So I can decide to take this to this side of the equation and bring this here. All right, so that H and H can be on one side of the equation. So if I do that, if I take this to this side, or let me say, okay, subtracting 2HS to both sides of the equation, 2HS. If I do that, I'm going to get 2hs minus, oh, sorry. I'm subtracting 2hwd to both sides of the equation, minus 2hwd. All right, I'm subtracting this to both sides of the equation. All right, so if I subtract this to both sides of the equation, I'm going to get 2hs minus 2hwd equal, here I have minus wd squared. All right, if you look at that. All right, but we can, instead of going through that, we can just take this to this side. We have wd squared, and we have 2hwd, and we'll bring this to the other side. We have 2hs. All right, I'm just trying to do this using, all right, so here we can factor out h here because we want to make h the subject of formula. So we have 2hwd minus 2hs equals wd squared. So here we have h, if we factor out h, we'll have 2wd minus 2s equals wd squared. All right? So now we'll divide through by 2wd minus 2s over 2wd minus 2s. So this will cancel out this. So my h will be wd squared all over 2wd minus 2s. So that's it. All right? So thanks for watching my video. You can always subscribe on OG's Wealth of Maths. Share my link, make comments on my video, and share your views. Thank you, and have a great day. Yeah, bye.